Hi, my name is Mark Pond. I'm a first LEGO League coach, and now in my 10th year doing this. And I'd like to share some tips with you about how to build a robot. I'm not going to discuss programming. There are plenty of tutorials online for that, and the kids will figure it out faster than us adults ever will. But I'm going to talk to you in two videos about how to build a competitive robot. The first video, which we're doing right now, will be about the robot chassis. Second video will be about sensors and attachments. Again, not programming, and I'm not going to guarantee you're going to win anything. It's hard and there's a lot of work involved, but you and your kids can have some fun with it. To start out with, I look for three things in a robot. I look for it to be sturdy, I look for it to be consistent, and I look for it to be flexible. Sturdy, I think, is pretty obvious. It's going to be handled by kids, not scientists in white coats. Kids are going to be handling it. Occasionally, adults who are in a hurry, your robot's going to get knocked around a little bit. You want it to be sturdy. That's one of the good things about Lego. You're going to want it to be flexible because you're going to be trying to do different things with it. Some missions will involve lifting, some turning, some pushing, some pulling. Some will require driving over something. Some will occasionally involve throwing something. You want to be able to attach all the attachments and devices that you're going to need to accomplish those missions onto your robot chassis. And you want it to be consistent. Consistent because as your team gets better, you're going to be doing steps 1, 2, 3, 4, 5 to accomplish a series of missions. And while you're working on steps 3 and 4, you're going to need steps 1 and 2 to be the same every time. Okay? Sturdy, consistent, flexible. That's what you're looking for. The basic part, most fundamental part of a robot is what Lego calls the large motor. You see one here. It has mounting points here, 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 and here. The axle is located in this red part up here in front. The axles can go all the way through. You can put the drive drive wheels are mounted outside the motor. Sometimes people will push the axle all the way through and will have a gear on the inside to turn something else. Up to you. A normal mount is a horizontal mount like this. Sometimes they're mounted like this. Sometimes you'll even see them mounted vertically as a space saver type configuration. Up to you. Conventional, normal, most of the time mounting is just like this, works just fine. The cable is attached right back here. The wheels normally are mounted just outside the motor. Now this is one of the older, I think they call it a motorcycle wheel. This has been around for years. I like it because it gives good clearance and it's narrow. Sometimes it can help to have a narrow robot. But you can use something like this, works just fine, or even if you're an off-road kind of team, you can do something like this. I don't think your choice in wheel is going to determine whether you win a trophy or not. Do something that you like. It's up to you. In my demo robot here, you'll see that I've mounted the wheels just outside the drive motors. You'll see I've got the drive motors mounted. I don't know how well this shows up, but you can see I've got a beam holding them together back here. They're mounted on frames here. This is a pretty sturdy configuration. You'll see I have spacers between the motors and the wheel, and between the wheel and the frame. We'll get to the frame in just a moment. But you want to keep your wheels mounted a consistent distance apart so you get consistent turns. Over time, especially as you keep trying different missions, the wheels can move. And if you have them mounted, if you have the axle mounted on the outside, on the frame, as well as on the motor, your wheels will tend to remain vertical, stable, the way you want them to. You're not going to have any toe in or toe out, which does happen even on the wider wheels. So I like to see an axle going from the motor through the wheel with spacers and mounted in the frame. I like having a frame outside the robot. We're looking at this one. You're looking at this one, bottom to top. A frame will enable the robot, once it bumps into a mission model, to just keep going. It's not going to snag. You'll also notice I like to have rollers on the corners. This will enable you, again, not to snag on something. It will also enable you not to, or to be able to use the wall as a guide. I have seen robots snag on walls. The corner will hit a wall. I've seen it happen. It happened to one of my teams once. Rollers will help you avoid that. You can use the walls as a guide. You can also use with rollers. You can back into the wall and use the wall to help you get a 90-degree shot off the wall. Up to you. I like having rollers on the corners. You'll notice that I have a bumper in the front, fenders on the sides, bumpers in the front. You frequently end up having to bump into something. This enables you to do that. You also have, I don't know how well you can see this, places here and here and here where you can mount attachments as needed. This part up here, the brains of the operation, is called the brick. The brick has 4 ports in the front, if we call this the front, letters A through D. Those are for motors. 4 ports in the back, 1 through 4, excuse me, for sensors. Now this particular demo robot, I have all of, excuse me, all of them are being used. Okay, you will notice that the cables go through underneath the brick, go through frame pieces. I don't have cables coming out loose. Cables snag on things. Judges like to see good cable management. I say that as someone who's been a judge. You'll notice that we have a roller ball in the back here. Roller ball wasn't around when I first started coaching. I think it's a great idea. I like to use the roller ball in a tricycle with the wheels and the roller. Some people put just a skid, something like this in the back. Works. Some people will just mount a wheel in the back. It works just fine if you're going in one direction. A little tough on the turns. Some people will put a swivel in the back. That works okay. Sometimes the swivel comes back at a little bit of an angle and it gives you a little bit of an uneven start when you go back out. One of the things about the brick that I like to do, bricks have mounting points on the bottom and along the sides. I like to mount on the sides. There's a very simple reason for that. This. Kids invariably will lift the robot by the brick. You can tell them till you're blue in the face, lift it up by the wheels. Sooner or later, usually sooner, they'll lift it by the brick. Adults in a hurry, lift it by the brick. Spare yourself a little bit of a headache, mount it securely on the sides so that when, not if, when people lift it by the brick, your robot won't come apart. So, with that, I'm just going to give you one little piece of advice. Keep up with the rules. First Lego League changes the rules periodically, not because they feel like it, but because circumstances sometimes dictate a change in the rules. A mission model will not work the way they originally anticipated. So people at Lego are really smart. But during the course of a season, people will try different things, or they'll come up with questions that hadn't been anticipated, and a ruling will be issued. So keep up with the rules so you can make sure that what you're trying to do is what will actually get points for you at the tournament. Now, that will conclude this video. Our next video will be about attachments and sensors. Thanks a lot. Have a good year.